All right. We are live. Let's get some Kappas in the chat here. Good morning. Got a dope new pin. Sorry, what were you gonna say? No, so I'm gonna mute myself on Discord here once we start class. Because then my writing would be like lagging with my speaking. So when I ask you guys a question, there'll be a pause. Yeah. Alright, how well does this guy write? Woo! I can write so fast. Alright, nice. Let's see, can I change that? Preferences. Looking at latency. How much was the lag? Like 5 seconds? Woo! Alright. Yeah, 7 seconds sounds like it's about the best. It's alright. Yeah, it just means when I ask a question, it'll be a bit before you can answer it. Interesting. We'll figure it out. There's something I was looking at earlier. Are you just chilling at home? Nice. I need too many monitors to work from home. Alright, that's gonna happen from time to time. Let's see. Yeah. I mean, Lonely Screen's the app. But also I'm lonely. Yeah. If you have background noise at all, then yeah, definitely mute yourself, and then you can just hop on or unmute yourself and ask a question. Or you can text in the Twitch chat or Discord chat. I'll have everything up. But I think you guys are comfortable enough talking that you can just use the voice chat. That's probably the easiest way. Unless there's like no break and you want to type something out. But yeah, it was pretty quiet in a couple of my classes yesterday, and they were trying to type, and it like takes a while because I can see them typing, and I'm just like waiting for their question to appear. It's just like faster to just ask it. Also, I think we can share on Overleaf. Let me try something. What a loser. No, I'm just kidding. You should make an account, man. Twitch is the best. Yet. Yeah, but it won't be the last. Yeah. Dance game, indeed. Okay, so I can share. I want to turn on link sharing. Okay, so see if you guys can edit. So in the chat here, right? So I just put in an Overleaf link. See if you're able to get in there and edit. Looks like it. Yeah, all you have to do is link sharing. So I think we're good. We have no, you just have to link share. You can't share. But as long as you provide a link, God, that's twice. That's not a good sign. Okay, I only had it happen like once per class yesterday. So this screen mirroring goes through like AirPlay, and our Wi-Fi is like not the best, and so it always does this apparently. Yeah. So first of all, you should mute yourself. Okay. Yeah. Just like well, I'm going to be muting myself on the voice channel, so it's not going to matter here now that we're starting class. So I'm actually going to go to Twitch only now for my sound. That way you guys see my writing as I'm speaking and don't have a weird lag. Okay? Discord is faster. It's about 7 seconds faster. So when I ask a question, I will wait patiently for answers. But you guys can absolutely speak up in the live stream here because it's going to be probably faster than typing stuff out, but I will be looking at both chats if you want to type stuff out. And yeah, that Overleaf file, it looks like we can all share. So if you're feeling super quick on overleaf, you can tell me to like look at something. But yeah, we'll see how it goes. All right, I am muting. Yeah, you can do whatever you want. I literally just made it. All right, so now I'm on delay. Okay, so I guess first we talked about some logistic. Okay, yeah, you got to mute yourself, Devin, or do something like put headphones in. I hate my own voice. It's fine. Yeah, unless you want to say something, you should probably mute yourself. But also, headphones in general are a good idea to not get feedback. Well said, Jack. Okay. So I think we're good. All right. So yeah, we talked a little about general logistics yesterday. So daily homework is going to be for now due at the start of class, and I'm not going to require like the purple pen necessarily because we're going to have pretty nice notes because we're going to go through like everything on the board through my notes here, and I can export those and stuff, which is nice. Really? Yeah. You should be able to. My mic's working. Is anyone else? That should not be a thing. What are you using? Laptop? Here, I'll hop in Discord for a second. Are you using a laptop? Can anyone else not hear me on Twitch? Yeah. God bless. Are we good? Oh man, please mute. Yeah. I mean, at the very least, just mute yourself and don't use headphones or something. All right. Why not, man? Yeah, it's the dream. I have other people who watch me on Twitch. This isn't the first time I've streamed. All right, Jack, mute yourself. Click the microphone. Nice. Okay. We're good to go. So let's see. Yeah, so daily homework, due before. Because of notes, at least for now, I'm not going to require like purple pen or whatever color you have available. But I will look at those and try to give feedback either typed or written on the iPad, since I just got a new pen. Like I said yesterday, problem sets, they'll still come around the same amount of time, like every other week or something like that, but we will definitely have easier problem sets just because office hours, even for like sharing overleaf or sharing screens or like live streaming or whatever, it's just not going to be the same as being in the office. And so I think doing those at the same level doesn't make a lot of sense. And, I guess I was planning on having all take-home tests anyway, so I don't think that's really changed all that much, which is kind of nice for us and really tough for Calc 2, but that doesn't really affect you guys. And then the last thing is we'll have a project. Let me turn this on. So similar to abstract, we will plan on getting those up, so I'll post these maybe in the next day or two. And also, I guess, give you a little bit of time over the weekend and end of this week to think about what interests you. And so, choose by next week. That way we get an earlier start than we did last year, and you can kind of spread out your work on this project over like a long period of time. And so basically the plan is to have like a general outline in early April, and then might even do like a draft. I haven't decided yet of how many steps I want here. We'll see how detailed the outlines are, I guess. But I'll just put like draft ? In mid-April, and then due before finals. Okay. So that's the only other thing really. And colloquium summaries. I think most of you guys attended my talk and Devin's talk, and so are already done once you write them. But if you did not attend those, obviously not going to have a whole lot of colloquia the rest of the semester, is my guess. I don't really think we're going to be coming back. And so I can just post like YouTube videos of talks that I'll post like a whole bunch of them, and you can like choose one or two to watch and then write about. Okay. I think logistically that's about all I had planned. I guess some people mentioned Zoom yesterday. I am going to look into that more, but I heard that as the day went on yesterday, Zoom got busier and busier, and we do have like a limited amount of licenses here. And so, I mean, it was definitely better than conferences on Canvas because lol, but it wasn't amazing. And so I am concerned a little bit about using that, but I know the screen sharing might be really nice, so I will continue to consider it at the very least. But for now, this is the platform I guess I feel most confident with and know roughly how it's going to work. Office hours, I guess, right now are the ones posted on the syllabus. Although I'll have a couple issues, like Thursday morning, I think I'll be making up an oral comp, probably via Zoom or something. And so I won't be available, but I'll like email about that. But I might be making different office hours later for like different classes. That way I can like really pay attention to certain things. But for now, it'll just be like the posted ones, and then you can like email me, or if I'm around Discord, I can hop in and talk to you guys. And you can always just put a message in a text channel and just be like, look at the overleaf file. I wrote something down. Does it make sense? I'll check it out. Any questions on anything? And you can unmute yourself if you want to ask it, or you can type it. No confidence in the unmuting. Other people exist, Nick. It's not just our class. I don't know. My office mate might be watching from grad school. I don't know. Still no daily homework for Thursday? What do you mean? There's going to be daily homework. It's usually posted after class, right? Oh, right, for the test. I was just like, oh, gotcha. Yeah. No daily homework. Yep. Sorry, I thought you meant for some other reason. I was confused. Yes. Boggers. Who cares? Any other questions? Is this a talk show or a podcast? It's a great question. It's really a class disguised as a talk show / podcast. This is how we do school now. But you can't see what they're saying. Nice. Okay. All right, let's get into it then. So I will occasionally like pause for things, and you guys can like talk in the live stream on Discord. But yeah, we'll see how things go, because there is obviously going to be a bit of latency. So I guess I'll just kind of put the number here. So the first one was, if you're a Hausdorff space, right, then you can only converge, a sequence can only converge to 1 point. I mean, or 0, so I'll say, yeah, at most. Converge to less than or equal to 1 point. So the idea here, right, is we know the picture of Hausdorff, right? So let's say Xn converges to X, right? So if it converges to nothing, we're done. And then if it converges to this point, let's just show that it can't converge to a second, right? And so can Xn converge to Y, where Y is not equal to X? Well, we have our little picture here, so maybe I'll make it open looking, and then here's Y. And since it's Hausdorff, right, we can draw it exactly like this. We have open sets that do not intersect each other. So say this is U, and this is V, and we have U and V are open with empty intersection. And so if we have a sequence that converges to X, maybe it dips in here, right? So like this is like X1, X2, and we're moving in along this. Maybe it tracks in there for a bit, but then eventually, right, all of the points will be inside U, right? That's by definition of convergence. So we know there exists some capital N such that Xn is in U for all n greater than or equal to capital N. But then what does this mean about Y, right? I mean, we see that this guy, maybe it's in there for a bit, but eventually all of these points from your sequence are in U, but U intersect V is empty, right? So xn is not in V for all n greater than or equal to n, so xn cannot converge to y, right? So we cannot converge to a second point if we're Hausdorff. Any questions on that one? All right. Yeah, I'm sure there's more than one way to do it, but I think that's fairly quick. Did someone want to talk about 129? Or at least A? Because I think that one's pretty easy to verbalize or even like type out. Ah. Right, so this one is R with the lower limit topology Hausdorff, or not? Cool. Yeah, so if a topology is finer than one that is already the Hausdorff, it's going to be Hausdorff, right? If you wanted to do explicit ones, right, we did like midpoint. If you have like x not equal to y, say y is greater than x, you could also do something a little bit nicer here, right? And that you don't have to worry about a midpoint. You can just do this half open interval that's open, and then y to anything. When we talk about points in a topology, does that refer to the elements inside of it or the points x inside of the superset x? Points would be in the set. We don't usually say points in a topology. Is that how it's written? So we would say points in the topological space, sets in a topology, or like elements of the topology are open sets. So that's like the distinction there. I don't know if I said points in a topology. I usually try to say space. Points are just points, not intervals. So long as your space is not one of intervals. Right, like I could do something dumb, like say X is the collection of all AB such that A is less than B, and then your points would be intervals, right? But yeah, for most of the things we're dealing with when it's like the real line or something like that, then yeah, points are points. Okay, so B was R with the countable complement topology. So this one was fairly similar to what we talked about with the finite complement topology on N. And so maybe I feel like I have a semi-quick way. I mean, it's basically the same thing that I argued last time, but maybe explained more concisely. Yeah, I can export these to Canvas for sure. I'm like 99% sure. I haven't actually done it yet, but I assume that's super easy with the iPad. Yeah. Okay. So this guy is, what do we think? Is this Hausdorff or is this not Hausdorff? Yeah, and indeed. And so here, right, like you just take x and y. I don't know why I keep writing a comma. Let's just say x is not equal to y. Here it doesn't really matter which one is greater. The idea, right, is if it is Hausdorff, then we're going to be able to get open sets around our points that are disjoint, right? And so we've got this. Okay, but what does it mean to be open? I'll just clarify these guys are open, right? So if these guys are open, then we know U complement in R, so R minus U, or I'll just write U complement because I'm lazy and I much prefer this. We know it's inside R, is countable, and V complement is countable. And so the idea is we have these open sets that basically have almost all of the real numbers except for a countable amount, right? And we know that they're just like way more than that because it's uncountable. And so, Rippy, question? No? Okay. Yeah, exactly. So basically the issue is going to be exactly with this intersection, and so this is what we should check. Right? So if U intersect V is empty, why does Rippy's voice come out of my computer and not my headphones? I don't know. It might be because you have your headphones hooked up to hear Twitch and Discord has different output. Yeah. Rippy is just a worm in your brain. All right. So what if this was empty? Well, then R minus U intersect V or U intersect V complement would be everything, right? But we have De Morgan's laws, and so this would mean that U complement intersect or union V complement is R. But what do we know about this guy? Both of these are countable. This is countable, right? As a union of countable sets, countable union or finite. Sorry, a finite union of countable sets. And so this guy is definitely countable. This guy is uncountable, and so we get a contradiction. Right, and so thus they could not have been Hausdorff. We could not have had an empty intersection between these open sets. Which again makes sense. We don't have this terminology yet. It's something you would see more in analysis, but if you're open here, you're going to be dense in the reals, and that's kind of the issue. That like countable sets basically take up no room inside an uncountable one. So, as mentioned before, we're going to kind of skip boundary stuff. You could also use the previous theorem pretty easily. Oh, you mean like 128 and using convergence? Sure. Yeah, you could also construct a sequence that converges to two things as well. Yeah, for sure. So maybe I'll make a note there. Could also sequence converging to more than one point. $127? What is 127? 128 actually works too. singleton sets are closed. Yeah, because we proved that 0. Listen, oh, okay, never mind. Yeah. Gotcha. Or 127 singletons are closed. Closed, and here, right, 0 closed if and only if R minus 0 is open, but wait. Oh, yeah, never mind. We would want to, yeah, okay. And its complement is countable. Oh, right. I'd be afraid to try that convergence stuff. Oh, it's not too bad. Right. And so, yeah, 127. Okay. Convergence, it might be worth doing. Maybe I'll make that a problem set problem. That sounds interesting. Yeah, no boundaries. So boundaries, it's just not really anything new. It's just a definition, right? So, I think it's at least worth saying that it's the closure minus the interior. And think about it, like with our unit disk, where we have all this stuff, right? The closure is the whole thing, right? It is like the closed ball, radius 1 around your point X. And then, so that's your A bar. And then the interior is exactly the open ball. And so what do you get? Well, if I make this the origin, let's just say X is 0, 0, because I'm lazy, then you get exactly the unit circle, right? And that's kind of what you would think is the boundary of a disk, right? That the circle is a boundary of a disk, and it turns out that is true. So that's nice. Again, this is something I'll put on a problem set a little bit to deal with, but the stuff on that page is relatively straightforward and just kind of computing stuff. It does mean that, yeah. Absolutely. Yeah, so if A is clopin, A bar equals A equals the interior of A, so boundary of A is empty. And, we've seen stuff where, like, think about Q, right? Q bar was the whole real line, but then no open interval was contained inside Q, right? Because any open interval is going to have an irrational. And so we had the interior of Q was the empty set. And so here, the boundary of Q inside R is all of R, which is also kind of weird feeling, I think. What? Yeah, again, when you're right, the boundary isn't necessarily thin. So in yeah, it works well for like open intervals, open balls. It's like exactly what you would think, but sometimes weird stuff can happen, especially when you take very specific kinds of subsets that you're considering. All right. Moving along. So we've got the subspace topology. And this is a big one, right? Can we think about boundary like another complement? Can you get on voice chat, Jack, and ask that? What do you mean? Well, Oh, okay. No, so not exactly. Right, so here, you can unmute. Or sorry, mute. Yeah, so, I mean, just look at these examples, right? So, I mean, it's not necessarily a complement. Ah! Let me kick you. Alright, I can't do this. Please mute, Jack. Mute. Alright, I'm just gonna mute you. Okay, so if you have to talk again, I'll mute you, or I'll unmute you. Alright, so yeah, it's not exactly that, right? Because this one, like, I mean, for Q, right, its boundary contains itself. And even with the circle, I mean, it's kind of the stuff that meets the complement. But yeah, it's never part of, it's never like a subset of the complement. I don't know. Yeah, I don't think there's like a nice way to think of it like that. I really think of it in terms of kind of the gap between being open and being closed, right? Your interior to your closure. Like how close are you to being either? And what's the gap in between? All right. X is the closure. Sure. Yeah, if you reduce your world and take a complement of a different set. Yeah, okay, sure. Yeah, no, I mean that makes sense. Sure. All right. So subspace topology is a super important one, and again, this is kind of one of a few that we're going to get, and this should feel a lot like what we did with group theory, right? So we saw subgroups, then we saw like Cartesian products of groups, we saw that that's still a group, right? And then we saw quotient groups, and we're going to do the same thing here. We're going to have the subspace topology, we're going to have the product topology, we're going to have the quotient topology. And you might imagine that these exist in a lot of worlds, right? So I mean, this also happens with vector spaces, right? It works with rings, it works with modules. You don't know what those are, but basically the point is these are very generalizable things, and it's not an accident that we're studying these three objects. You know, these are very universal things. So subspace topology is kind of the thing that makes sense, right? You have a subspace. All right, cool. We have a subset of X. We have a topology T on X. Then, all right, what's an open set in A? Well, I already have a bunch of open sets on X, and then I want it to be inside A. So what do? I just intersect it with A. Now it's inside A. Cool. Those are open sets. So topology on A is exactly U intersect A, where U is an open set in the topology on X. Seems very natural, hopefully. And so the first thing we should check, right, is this a topology? And I mean, it should follow pretty quickly, right, from T being a topology on X would be our hope. So first we should check, are the empty set and A itself open? Yeah, I can draw a picture. Okay. So this is my X. In here is my A. And so then if I have some open set U, right, then what is the open set I get inside A? It's this guy here, right? And so notice that, I basically include this boundary now, which was closed, right? I didn't like dot that guy before. And that's kind of what we'll see here in this exercise, like 138 or something, that you can now kind of include things that would have been boundary points before, endpoints of intervals, the circle boundary on an open ball. Those can be included now when you intersect with A, right? Because like we have the dots out here, and so when we restrict, we suddenly add like the edge of A. And so this would be our U intersect A in here. Wow, that's not very visible. I'll just do it in black. U intersect A. Okay, and so that would be our open set there. I think so. So I mean, it is not a restriction. So yeah, not everything that was open before is still open because not everything is included in A, right? So I guess it should be clear, and maybe I'll wait on this part here, right? So if U is in T and U is contained in A, U is still open in TA. But yes, you can get things exactly what Rippy said. Yeah, so you can get things like that. So we have the example down the line, right? If A is 0, 1, then we can get I don't know, 0 to 1/2 is -1/2 to 1/2 intersect A. Right, and so this guy is open in R with the standard topology, and then we intersect it with A, and so we can suddenly get half-closed things. But it's important to notice that the only half-closed parts we can get are the left endpoints and the right endpoints, right? So we can't get something like, 0 to 1/2 suddenly open here. Is that breaking any topological definitions or just redefining a new topology with slightly different rules? It's not breaking anything. So, I mean, we're just defining a topology on the subset, right? So if you didn't already have a topology on A, which is very possible, right? You can view A as like an X itself, in which case like everything just starts as subspace. And so like if you had the standard topology on A, for instance, yeah, I mean, usually you just view it as a subset. This is like a new way to define a topology. Yeah, exactly. We're going to prove that it works. Okay. All right. So, right, empty set in A, R and T A. Why? Well, empty set is, well, you can intersect with friggin' anything, but yeah, intersect the empty set with A, you get the empty set. Cool. That's open because the empty set is open in T. And then we have that A is X intersect A, right? And so X is in T, so that also is open. Oh yeah, we absolutely have a bot. He's going to be my new friend though. Okay. Next thing, and the next two are very, very similar, right? And they just kind of rely on distribution of intersection over union or vice versa. Or I guess, no, the other one is intersection over intersection. So here, we start with some things that look like, right? So like, what are open sets in this space? Well, they look like open set in X intersect A, right? So where U alpha is in T, so an open set in X, and we want to show this is open. So we need to show it's some open set intersect A. And this is where we can just distribute, right? So this is exactly the intersection with the whole union. I think we have proved this previously. It's pretty quick to see that these are equal, and this is the key thing, right? Because this is open since T is a topology, and so it's closed under arbitrary unions, right? That is closed under unions. All right, and then our other part here, if we have a question. So we would start with a finite intersection. Oh, all right, I will wait and let people type, or you guys can hop in the voice chat if you want. So is X in both the topology on X? X is not, right? So unless you're taking the whole subspace, but if A equals X, then the subspace topology is the topology itself, right? So you have to intersect with A. So X intersect A gives you A. So that's like the biggest thing in the subspace topology. Yeah. Cool. Okay, and so this one is, again, just distribution, right? So we get finite intersection of the UIs. Again, this guy is open because T is closed under finite intersections, right? So this guy is open, T is closed under finite intersection, and then we intersect that with A. And so we have open set intersect A, and so this guy is still open. So we have all three of our things, and we've got a topology. Okay. Now let's run down the list here. So I think this is one where somebody take 138. So Jack, how about you do 138 and just type out either open or not open for 1 through 4. May Riley want to take 139 and Rippy 140 and Will 141. And then if you guys just type out open or not open, I can actually write an actual thing on here. I just want to get some involved. Or you can explain it to me if you want. That actually sounds way better. You can type it up and then you can hop on the mic. And Jack, I will unmute you, by the way. So you can unmute yourself when you want to talk. Right, so here we have R with the standard, and A is 0, 1, so this is X. And so we've got 1/2, 1. Here, actually, sorry, there are only so many. Here, Jack, how about you actually just, I think typing is dumb here. How about you just hop on the mic and run me through these? So unmute yourself. Okay, yeah. Cool, thanks. Yeah, I agree. And we already know basically for x how this works, right? So it's really like y is open in A. So I can give examples here. So like 1, right, you can do 1/2, 3/2 intersect A, for instance. 2, you're already good, right? It's already inside A. And then 3, just anything that includes 0, right? So I don't know, -1, 1 intersect A. And then the issue with 4 and why it's not open in A is that, like, it's fine to include 1, but it's not fine to include 1/2, right? Because we would have to have something like it's either this intersect A itself, or it's 1/2 to some other point, call it B, where this is either open or closed. And in either case, right, this guy is not open in X. And so we can't intersect with an open set. Here, Riley, if you're ready, you can also just like unmute and talk me through 139 if you want. That might just be faster. Yep. Yep. Yeah, you're right. Yeah. Yeah, you could just take this one, for instance, right? 1/2 to 3/2, because we know that the lower limit contains all of the basic opens from the standard topology. Yep. 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 Exactly. Yep. Yeah, so definitely not in X, and you're right, it is open in A. Can you see what it's the intersection of? Or what you could make it an intersection of? Well, we're going to 1, right? So you want to have it on the other side. So yeah, so here just basically anything that includes 1. You could do like to 3/2 again, you could do to 2. Anything like this would work. All right, thanks. Nick, you have a question or comment? Are we ready for Rippy? Okay. No, not for now at least. I just don't see the point, especially if I'm going to be like posting them. Yeah. Sorry. Go ahead. Yeah, so maybe this guy, for instance. And here. How are you doing 1? Yeah, I think it's the same issue as with 2, right? You have something a little bit bigger than 1 or something a little bit less than 2 has to be included. Yeah. Okay, cool. And then what about 2? Mm-hmm. Sure. Yep, exactly. Cool. 감사합니다. All right. Will? Yeah, this one's already inside A, so yeah, that's pretty clear. Oh, God. Mm-hmm. Okay. Yeah, sorry, let me catch up a little bit. Right, so this guy is not in either, and this is basically the same reason as 4, with like 138, right? That the issue is we could include, like, these are okay to include, but these are not okay to include, right? We can include the boundary ones, but we can't do stuff inside. Yeah. And then 4, sorry, can you just maybe type, what did you say for 4? Yeah, agreed. Again, the issue is we have included these guys, right? Same reason. So not in either. And 5, you're right, is open in both. And I mean, it's clear as open intervals union in the standard topology, but also all of these are already inside -1 to 1, right? So I mean, this intersect A is itself. So it's clearly going to be open in both. Also, brief little comment, something to pay attention to when I was grading the problem sets. N+1, that is a number bigger than N. 1 over N+1, therefore, is smaller than 1 over N. So this is the correct order of these. Saw a lot of intervals from 1 over N to 1 over N+1. We like to be left to right in our society. It's fine. We live in a society, guys. But yeah, we're good. All right. Wow, all of you are Hebrew. That's crazy. You have such non-Hebrew names. It's wild. It's good stuff. Good, clean, good, clean family fun right there. Cultural assimilation. Facts. I assumed nothing. I assumed your name was not Hebrew. Because it's not. Oh God. All right, moving on. I'm sure. Yeah, Irish Hebrew, very common. Nah, it's a great joke. Okay, so I think 143 is going to end up being a problem set guy, although it's not very hard. But I felt like I was running to the limit of how many problems I could reasonably assign, even though most of these were very computational. So 142 is an important one, and we'll talk later about some other topologies with these coming up. I don't know. I was doing it when I was in Fishers at some point and working on these problems. That there's some interesting topologies you can get by using different. Well, these are more quotient topologies, but it's kind of cool. But for the subspace one, this is just very straightforward. What topology do you get on Z? Inherited by or induced by the topology on R? What is the standard topology on Z? No. No. So what 144 is saying, I'll let you guys hash it out. Can I explain? Okay. Yeah, so you're both right. So what Rippy is saying is like, look at 144. Like I state afterward that the topology inherited from the standard topology is called the standard topology on the subset. Okay, so you're right. This is the standard topology. The issue there, right, and I guess like why it wasn't fully hitting the point is that's not really illuminating as to what the open sets are, right? Because if you just hear standard topology on Z, well, you get kind of the issue here where Devin and Nick, I think, were like, oh, but there are no open intervals here, which is true, but that's also not what we're saying, right? The standard topology on the subspace is just intersect standard topology things with your subset. And so in this case, you get the discrete topology. So the discrete topology on Z is the standard topology on Z inherited from the standard topology on R. Does that make sense? Right. Saying standard topology on a subspace basically tells you where it came from, but it doesn't tell you what it is. And so that's why we would want to go a bit further and say, oh, we can recognize this. We actually get the discrete topology. And basically it's exactly by what Nick did there, and I'll just generalize what he did, right? Any singleton set is just, n minus 1 to n plus 1 intersect Z to get anything being open. I also want to make a little comment here. I use this word induced. I don't know if you've really seen this much before. I feel like I mentioned it at some point in group theory because I don't see how I could not have, but I don't remember having a discussion like specifically in my mind. So basically, right, you could either say inherited from, where you're really talking about like Z getting it from R, or you can say that the thing on R induces the topology on Z. These are basically the same thing. Okay, so it's just like a little bit different phrasing. Wrote a proof for the discrete topology in the LaTeX. I mean, yeah, that's pretty much what I had. You just had a little smaller interval. Looks good. So induced by is something we'll see more with the quotient topology. And in general, induced is like a word used a lot in mathematics, especially if you're getting properties inherited from things previously known, coming from a coming from a superset or something like that. Okay. So 145. Ah. Right. Okay. The same topology on Z is the answer. That's great. Okay. So basically, this is another thing that you would just like hope is true, right? So I mean, how do you get an open set with a subspace? You intersect it with the subspace from the open sets you already have. If you already have a basis for the superspace, sounds cool. How do you get a basis for the subspace? Again, you just intersect the basis elements with the subspace, and then it just falls to us to actually show that that still satisfies the definition of a basis, right? So, does anyone want to talk through that one? All right, we're good. Shouldn't be that weird. All right, sounds good. Yeah. Hold on. So wait, what are you trying to show? But what definition? Yeah, so I think that's more what I was looking for, right? Why not? That's the easier way, I think. Oh, okay. Yeah, but that. Oh, okay. I see. And then you're using the fact that you do know the open sets already. Okay. Yeah, I'm probably gonna go ahead with like the more standard one. But I think that would also work. Yeah. Rippy, did you feel good on 2? All right. I mean, either way, let me write 1 in the first place. Okay. So, right. If x is in A, well, we already know x is in B for some B in script B. And so x is in B intersect A because x is in A, which is in BA. So that's 1. And then the second part, right, is we would have to show if x is in the intersection of 2 of these guys, right? So like B1 intersect A, intersect B2 intersect A, then there exists some other open thing in there, some B intersect A contained in the intersection, this contained. Mm-hmm. Yeah, so what's the finagling that you're doing? Yeah, so I think writing it like this is very effective then, right? And this guy is a basis element, right? This is in B. Yep, and then we know since B is a basis, there exists some B in B with X is in B, and that's contained in this intersection. So X is in B intersect A. Sound good? Cool. And yeah, I think, Devin's way works as well. Yeah, whatever works. I think for me, I typically just think of like the very, no pun intended, basic way of doing it, just because these simple two conditions are pretty easy. But whatever works, works. Don't pander. No, we made it so long. We're good. Yeah. I just have to turn the Wi-Fi off and back on, and then it's good. All right, so what about this last one? So somehow we made it through the whole thing. So 146, right, is we've got S1, we've got our unit circle. What are the open sets if we view this as a subspace of R2 with its standard topology? And again, with its standard, right, we know that we could use open balls or open rectangles, and you should get the same thing pretty much either way. Does it have to be a single arc? Depends on what you're using. Right. Yeah, correct. Also correct. Right. Yeah, so depending on which way you do it. So if you use open balls, maybe open balls, just arcs, open arcs, right? So like not including the endpoints there. So like these are open, if you will. And then if you do open rectangles as your standard basis, then you either get arcs or union of open arcs. Yeah, for sure. And that's going to be important down the line too when we, yeah, that's going to be important down the line when we think of like mapping an interval onto the circle and basically like, yeah, unraveling it and kind of like what happens at the glue point is what makes them like not homeomorphic or equivalent as topological spaces. All right, well, that's the end of class time. I can be around for a little bit if you guys want to chat about anything. And then I can post stuff and yeah, I can export this later. And then I have like my contingency review on like who I am as a professor meeting with Dean Lamberton tomorrow, so I'll be like a little bit busy today figuring out exactly what I'm doing for that. But yeah, I'll be around. And we can chat. You can use the overleaf thing, whatever works. I appreciate it. I mean, yeah, I don't think I'm like at risk of being gone. For sure. Here, I'll quit the live stream. I guess actually there's no point. This is the easiest way to write, so I can do that. I can just keep this going, to be honest. Yeah. Yeah. But yeah, I'm not going to be as available as I am in the office. Yeah, so like right, like in the office I can eventually just kind of go home and there's like a distance there. If I was just like answering things anytime I'm at my computer, I'd literally be available like 16 hours a day and I just can't healthily do that. So I mean, the plan is roughly like my planned office hours and then, I'll be around sometimes and like I'll come in like uh I'll check the Discord or I'll check the overleaf thing, but I won't like be sitting in there throughout the day. Those will be during like my set office hours, which I may add to a little bit, but I won't have all the time. Yeah, well, I mean, if you want to do a private call, you should probably chat me first and ask if I'm free. But um, yeah, and if you want to like schedule something beforehand, like feel free to email me or private message. Right now, yeah, probably. Yeah, I mean, I check it a decent amount and I get notifications. Nah, chat's for losers. Sorry. I can check chat for Kim's. Oh, do I not have the solutions posted? My bad. No. I mean, if you couldn't find it, it's probably not up. I have. Oh God, I hope I. It doesn't matter. You can see my lonely screen. You don't need to see it right now. That was problem set 3, right? That was problem set 3, right? Yeah, it's up. It was posted March 6th. Like, gotcha. Yeah. I am waiting on my friend to mail me stuff. If I have extra time, I can just rewrite like entire solutions for it. Otherwise, I will probably scan those to you guys in a few days. Um, yeah. I can probably write it up later. But I left my folder on his. That was the one thing I left in Virginia. Yeah, and I mean, it was clear from discussion that you did it. I'm not like concerned about you not having done it. Yeah, print to scan seems like a great idea. Or sorry, print to PDF also works if you have like a laptop. Like I can usually print files to. I guess yeah. Never mind. Like take a picture and then print it to PDF or something if you don't naturally have a PDF file. But like Cam Scanner should work. Yeah, there are a lot of apps. Yep. Nope. And I will also be probably streaming Hearthstone this weekend if you guys are feeling isolated at home and want to like hang out and not talk about math. But not constructed. Oh, for that, yeah, you just like go on Twitch chat and throw a bunch of pogs. No. Wait, Pepe Hands doesn't work on here? What is my BattleNet? It's also Buck Nasty ZB. Oh, what's the number? That's a great question. I haven't logged on since Halloween. I don't know. You can probably find it on the interwebs, to be honest, if you search me in Hearthstone. It's Buck Nasty ZB. I want to say it's 1970, but I'm not 100% sure. You just stream snipe me. Yeah, I'm not playing Constructed, so good luck with that. I don't care. If I do Constructed, I'm gonna like fall apart as a human and become good again and not do math. For sure. For sure. Any. Think about it as. I didn't actually leave the stream, but I can end the stream. Yeah. I'll just do that.